Maintaining a differential temperature between lean amine and feed gas is one of the most common rules of thumb of amine plant treating that we see all around the world. But the thing is, it's not always required. And if it is required, what should that differential temperature be? There's a lot of unknowns there, and we see a lot of incorrect operation as a result of an incomplete understanding on how to set lean amine temperature. So pay attention. We are going to cover the fundamentals of lean amine temperature setting. It's going to help you optimize your amine system as we go into the hot summer months.
Welcome to the Experts Network.
Everybody, welcome back to the Experts Network. Thank you for joining us. My name is Ben Spooner. I am an engineer with Amine Experts, and today's topic is comes to us from a gas plant client of ours up in the state of Colorado. And their question is, what should my lean amine temperature be? So the amine going into the absorber, it's coming right out of a cooler, which has a set point. What should it be? Okay, it's a question we get a lot, and the general rule of thumb, if you ask most operators around the world, they'll tell you, well, set the lean amine temperature around 5 or 10 degrees warmer than the feed gas temperature. That's what most plants do. And if you don't have any further data, that may be the best initial strategy. But you can definitely fine-tune what that temperature should be. Let's have a look at what happens to the gas as it enters an absorber, okay? So if you look here, what we've shown is a temperature profile of a typical amine absorber. As soon as the gas enters the bottom of the absorber, the very first thing that happens is that there's actually an increase in temperature. So it doesn't matter what temperature the gas entered the absorber, right away it gets heated up because of the exothermic reaction between the acid gases in the gas and the amine. So the amine and gas heat up in the bottom of the absorber, but as the gas bubbles its way up and we remove acid gas, the intensity of that exothermic reaction gets lower and lower. And so in the top half of the absorber, we really don't have any temperature at all. And so the gas cools back down until it reaches the same temperature as the amine. This is where our concern is. If our amine is too cold, we could potentially cool the gas down so much that we condense hydrocarbons. We condense gas phase hydrocarbons to liquid. And at that point, we now run the risk of foaming in our absorber. Okay, so that's why a lot of operators and people have learned this the hard way. They're like, I have to keep my amine warmer than the feed gas or I wind up with foaming. But the question is, will you condense hydrocarbons, yes or no? And if so, at exactly what temperature does that happen? And so rather than follow a rule of thumb, a much better operating strategy is to know the hydrocarbon dew point. You need to know the temperature and pressure at which your composition going through the absorber will either be a gas or a liquid or a combination of the both. So what you need to do is get an analysis of the treated gas stream. Okay, analyze the usual H2S, CO2, all that stuff, and hydrocarbons, but you need that hydrocarbon analysis to go as high as you can, all the way up to C8 or C9. Okay, beyond that, not really necessary because there's not going to be much gas phase, C10, C11, etc. So up to about C9 we found is good enough. And then you put that into, there's all kinds of programs out there that can convert that composition into a phase envelope. Phase envelope looks like this. And what we have here is on the x-axis is temperature, and on the y-axis is pressure. And simply, you can see as we hold the pressure constant, but drop the temperature, eventually you cross what's called the dew point line. Okay, eventually you condense hydrocarbons. And so if we know the treated gas composition, we know the temperature and pressure which hydrocarbons condense, you just simply make sure your lean amine is warmer than that dew point temperature. So that's the true answer in how to set lean amine temperatures. Like, well, keep the amine a couple degrees warmer than the hydrocarbon dew point. Now, you may not have right on hand a hydrocarbon analysis up to C9 or C10. So what about using just some common sense to figure out whether your amine needs to be warmer than the gas. Let's take something like a tail gas absorber. Okay, tail gas treaters, they don't have heavy hydrocarbons. This is the gas exiting a sulfur plant. So it's mostly nitrogen, hydrogen, maybe they'll have some H2S, some CO2, little dribs and drabs of whatever, but there's not going to be heavy hydrocarbons that are going to condense and cause foaming. So in a tail gas unit, you don't need to keep a differential temperature between the amine and the gas. Same applies for an acid gas enrichment absorber. Same applies for most hydrogen recycle absorbers. All right, when you don't have these heavy gas phase hydrocarbons, you don't need to keep the amine warmer than the gas. Okay, but say you do have hydrocarbons. And so you do know that we do need to keep a differential temperature. Well, now the question is, how much? Should it be 2 degrees, 3 degrees, 10 degrees? It basically comes down to how much acid gas are you removing? Because, again, the reason for the high temperature bulge in the bottom of the absorber is because you're removing acid gas. But the more acid gas you remove, the more the phase envelope, that hydrocarbon dew point, is going to change as the gas bubbles up through the tower. So the treated gas is going to have a higher hydrocarbon dew point than the feed gas. Because we've removed H2S, we've removed CO2, it means the remaining hydrocarbons are at a higher concentration in the treated gas than they were in the feed gas. So the hydrocarbon shifts, the hydrocarbon dew point shifts to the right, and you can condense hydrocarbons easier. So that's why we keep a 5 or 10 degree differential temperature on high acid gas removal situations. Again, a simulator can help you really fine tune what the differential temperature should be, if one's even required at all. Now, finally, so our question came to us from a gas plant. Now, in a gas plant, they're going to have a really strict H2S level allowable in their treated gas. So one of the dangers of just blindly following this rule of thumb of keep the amine warmer than the gas is if the feed gas temperature rises, okay, and so the operator reacts by just increasing his lean amine temperature, increasing to maintain that differential, well, you can put yourself off spec on H2S, which kind of defeats the whole purpose of having an amine plant in the first place. In most gas plants, H2S spec is the most important thing that the operator follows. So there are definitely clients of ours where we have them running the amine at the same temperatures of feed gas or sometimes even colder. It puts them at risk of foaming without a doubt, and so we manage that with proper anti-foam addition. Okay, we make sure the anti-foam is effective, we make sure we know the dosage rates, all that good stuff. And just during those couple hours in the hottest part of the afternoon, we inject anti-foam to keep things under control while not going off spec on H2S. Now, I will give out one more scenario, and that's where there's a compressor after the amine absorber. Okay, well, when we have a compressor, we're going to have a knockout drum right before the compressor, and it's going to have not just a high-level liquid alarm, but a high-level shutdown, because we definitely don't want liquids getting into a compressor. Well, in those situations, foaming would be worse than going high on H2S, because foaming would cause amine to carry over, fill out the knockout drum upstream the compressor, and shut the whole plant down. Okay, so the overall answer to what should my lean amine temperature be is, well, it depends. Depends on the hydrocarbon composition of your gas, depends on what's more important to you, treated gas H2S spec or liquid carryover, but I hope we've given you a number of things to consider when it comes to setting your amine temperature. You definitely don't want it any warmer than it has to be, because your H2S removal will suffer. And furthermore, if you want to get into it, the surface tension of the amine is changed when it's warmer. It foams easier. So you can actually make your amine foam easier by heating it up unnecessarily. Lots of food for thought in this topic. Thanks very much for following us and watching. Please, subscribe to our LinkedIn channel and then hit the, what is it, a bell? It's a bell, okay? You'll see the bell, just hit that, and that'll make our producer happy. Thanks very much for watching, guys. We'll see you again next week.